Hello, this is for CIT 371, Linux System Administration. In this lecture, I'm going to be talking about security and firewall management. So this lecture is going to provide an overview of the process of Linux hardening, the process that we're going to use to make Linux systems more secure. Since we cover Ubuntu in this class, we're going to talk about UFW firewall. Now there are other firewalls available for Ubuntu or Linux systems, including Ubuntu, but UFW is the simplest and is very effective, so we're just going to cover that. It's also the one you're going to be using in the lab. Speaking of which, there will be an overview of that lab at the end of this lecture. So, an overview on Linux hardening. Now, the term hardening refers to the practice of making the configurations necessary to reduce a system's attack surface. So, it is true that Linux by default is very secure. It doesn't have a huge attack surface in general, but there are still ways we can further decrease it by making certain configurations. So, hardening can also refer to reducing the number of vulnerable configurations on a device that an attacker would look for and use to exploit it. So, I'm going to cover some steps in this lecture that you can use to harden your Linux systems. It should be noted that the list I'm providing is not comprehensive. Um, you could probably do multiple labs on Linux security, maybe even a whole course, but for the time we have, I'm just going to provide an adequate introduction to the topic of Linux hardening. I do want to cite this TuxCare article that I used to make or used to make this lecture. The following sections take information for also this Netrix and TuxCare articles. I use these two for this lecture. So the three rules of Linux hardening. So when you're hardening Linux systems, there's three general goals you want to accomplish. The first is to remove unnecessary functionality on a computer. So if your computer has a feature that doesn't need to be used, it may seem innocuous at first, but you'd be surprised. There are a lot of ways to take advantage of unused features on systems. So if you don't need a feature on a Linux system, then you want to disable it or remove it because it adds an additional entry point for attackers to potentially exploit it. So let's take for an example a USB drive on a server. Now, if you are not using that drive or that port, it may seem innocent at first because it can be useful for doing backups and stuff. But if an attacker did manage to physically get into your data center somehow and puts a malicious hard drive or flash drive into the server, it could cause some serious trouble. So it's better just to close those ports if they're not needed and only open them when they are needed and there's authorized people using them. The second rule or a second goal of Linux hardening is to apply software and system updates in a diligent and prompt manner. So the thing of it is, software patches are important. Doing system updates is very important, but as many Windows people can attest, definitely Windows people can attest to this. There are updates that don't always behave very well. They sometimes make your system worse, and Linux is vulnerable to that too. It's not a Windows only thing. But the thing of it is that software patches, they're supposed to go through some rigorous testing, but even the most rigorous of tests or test sessions can miss vulnerabilities and other issues that can affect not only security but availability as well. So the thing of it is that you want to patch systems as they come, and you want to do it in a diligent and prompt manner, but you also want to be careful when you do that to make sure you're not hurting your system by installing updates that have issues. Final rule or goal of Linux hardening is to ensure system configurations are enabled. Unsecured configurations can open holes in the system that attackers can exploit. So you want to be careful which ones are enabled. So the remaining slides in this section are going to showcase some ways these rules can be followed while hardening a Linux system. So for removing unnecessary features, all services, features, utilities, and software that are not required by a system should be disabled and uninstalled as applicable. And as I was mentioning, USB ports and other network ports should be disabled because they allow attackers to take advantage of systems. So if you have it open, like on a switch, if you have the console cable open, an attacker could take advantage of that. So in addition, unnecessary firewall ports should be closed, and you should only leave ones that are absolutely necessary, like your web one, your DNS one, and SSH if you need it. But all other ones, especially like unsecure ones like Telnet, should be closed. We're going to talk about the user accounts and authentication now. So user accounts that are unnecessary should be deleted. Like if you got some random like test account on a server, Linux server, you should delete it if it's not being used, because it is a especially if it's got an insecure password, you're just asking for an attacker to get access to your system. All necessary user accounts should have long, complex passwords. I mean, that should be pretty obvious. A memorable passwords you can store a memorable passwords in a secure password vault or on a piece of paper in a physical vault if you really need to. Like if you really want to use less secure passwords, you should at least store them in a vault. I would recommend not doing that though. Still, it's better to use you should use unmemorable passwords in a secure password vault. Yes, your passwords should be not very memorable. They should be to a point that you can remember them, but if they're unmemorable, like the less memorable they are, the more secure they are, the harder they are for attackers to guess or to brute force. Um, Thankfully, you can remember them if you put them in a password vault, which is I recommend. If your organization has a password vault, you should put your passwords in there. You should also enforce a password policy that requires secure passwords. It's good to store accounts in a domain, a centralized domain. Now, a lot of organizations can use a hybrid environment where Active Directory on Windows is used. If you really want to stick with all open source on Linux, OpenLDAP is an option. It is harder to use overall, but um, Windows Active Directory is really useful, and it's what we do here at NKU. You should also make sure to pay attention to service accounts. You don't want to give them a user shell, because service accounts typically have pretty high privileges, and if users can sign into them and get a shell to run stuff, that can be very dangerous for your system. We'll talk a little about SSH here a little bit. It's best to prevent root login via SSH. By default, that's enabled. That's one of those holes that that's an example of an attack surface that is enabled by default when you install SSH. You want to disable that. You should also enforce the use of version 2 of SSH. You want to set a maximum number of login attempts, so that will prevent brute force attacks. You want to make sure you don't have any accounts that use empty passwords for SSH, and you want to limit login to an approved list of users. So you don't want attackers just finding a random account, getting the password, and just signing in if that user is supposed to use SSH. System and software updates. So system updates are essential to a system's security. If you neglect these updates, your system can be attacked through recently or older discovered vulnerabilities. So you should apply system updates automatically to ensure the system is patched as soon as possible, or you can do this. But you do put your system at risk, like I said, if an update creates vulnerabilities or breaks certain features. What is far better is to apply updates in a non-critical system, like sandbox environment. Like you want to build a test environment for applying updates and see how a system reacts to them. If your testing proves that the update doesn't break anything, you can then apply it to your production systems. You can apply them automatically if you want to get the fastest benefit, but the testing of updates will prevent system updates from causing problems. These rules can also be applied to software updates, like to Apache, or if you have like certain applications or IoT devices or whatever. It's good to test your updates before you apply them. It should be known that many programs do not provide the option for automatic updates, which kind of ties into having to test them anyway. But there will be applications you will have to install or update manually, and you have to watch for these updates as they come, and then apply them as they do. So security audits and backups. Security audits should be performed regularly to ensure your system's configurations are set to best serve its security while also maintaining its usability. So it's good to frequently test the security configurations of your server to make sure there's no holes or there haven't been new problems introduced. Also important are regular backups. If you get a ransomware attack and your system's encrypted, it's good to have a backup. Or if something else happens that breaks a system, backups are great for restoring back to that known working point. It's also important to test your backups too. It's not good when you have an incident like a ransomware attack, then you find that your backups don't even work. That's really bad. So it's always good to have backups and to perform security audits to further improve the security and availability of your systems. Okay, we're going to shift gears to firewalls. So similar to Windows, Linux devices do come with a built-in firewall utility that you can use to monitor and manage incoming and outgoing network traffic. There are other firewall solutions you can download to your systems like IP tables and shortwall, but there are also dedicated firewall devices like Indian, pfSense, and IPFire. They're Linux. These two listed here, IPFire and Indian, are Linux distributions that are configured to just be dedicated firewall systems. The pfSense actually is based on FreeBSD rather than a direct Linux distribution. We actually use pfSense in this class, but I've used Indian in the past. It is a little dated, but it works somewhat similarly. So regardless of the firewall you use, most of them allow or block traffic based on the source and destination port and IP address. I do want to note one other thing is that it's good to combine a physical hardware firewall with software firewall. Like you can use UFW and pfSense. We use both in this class at the same time to maximize security. Speaking of UFW, it is the built-in firewall for Ubuntu. UFW is short for uncomplicated firewall. So, as its name implies, it's easier to use than like IP tables. We like to use it in this course for just a simple introduction to a firewall. Interestingly, UFW is disabled by default when you install Ubuntu. But you may think that would leave a Ubuntu device completely open to attack, but it actually results in all ports being closed by default. So it's actually the most secure configuration for your systems actually have UFW disabled. But after you enable it, you can allow and deny traffic based on ports, services, individual IP addresses, and subnets. I do list some common ports here. Not really necessary knowledge for this course per se. There is ports like 22 for SSH traffic, port TCP UDP 53 is for DNS traffic, UDP ports 67 to 68 are for DHCP, and then there's of course HTTP 80 and 443 for HTTP and HTTPS. Now we do use other ports in this course for Docker containers. You can, beyond these well-known ones, you can assign ones like 8080 for HTTP for your Apache server in Docker. Okie dokie. So, the Security and Firewall Management Lab will have you perform a number of hardening tasks on your Ubuntu server. They're going to perform some brief configuration audits, encrypting a file, disabling root login for SSH, and managing the UFW firewall. I will say there are a few commands given in the lab, but you will need to look up the vast majority of them. If you use the proper Google queries based on what I've said in the lab, you should be able to find the answer pretty easily. But that will do it for this lecture. I thank you very much for watching. I hope it was informative. If you need any help with the lab or understanding anything in the lecture, please feel free to reach out. Thank you and have a wonderful day.